Please tell me when I am audible and visible to all of you, so that we can start the class. Just let me open the chat. Okay. So we will continue with the climatology topic which we were studying. And yesterday we had discussed about the composition of the atmosphere. We had almost finished except for one, the pollutants we had to discuss. So I will be talking about that. If anyone has any questions to ask, you can ask me now before I begin the class. किसी को कुछ पूछना है? We were talking about very elementary things till now. Today also it is very basic climatology we have to study. And ये जो basic climatology है, we will continue it on this live on YouTube, open for all. So today, if you talk about, we will be talking about number of things. We will be particularly focusing upon two topics today. One is the structure of the atmosphere, and second, if you talk about, we'll talk about the seasons, because seasons play a very important role in how the temperature or how the insolation is distributed on the Earth's surface. किसी को कुछ पूछना है और should I continue? One pager notes, which what you are asking. If you would have seen today, there was one PPT I got uploaded today. This PPT, अगर देखा हो तुमने, तो I'll just scroll it for you. So weather and climate difference we talked about yesterday. So we talked about how when we are talking about the climate is not just if you talk about study of the atmosphere, but it is also study of interaction between the various spheres of life. We started discussing the composition of atmosphere. So we had seen that how air is essentially a mixture, and we talked about difference between homosphere and heterosphere. Remember, homosphere is the zone which is up to 80 kilometers. And in this zone, what we are finding is that there is, if you talk about mixing of the air, so thus the composition of the dry air is found to be constant within this homosphere. After that, we discussed about the composition of the atmosphere. So the primary, if you talk about gases, nitrogen, oxygen, and there were others, like for example, we talked about argon was the third most important gas. After that, there were all others, and all others we talked about, they were so much small that in percentage terms they doesn't make any sense. So thus we saw that we were looking at them from the parts per million point of view. And carbon dioxide, we saw that by 2025 what has happened, carbon dioxide concentration has very much increased. It has reached to 420 ppm, if you remember. So we had seen this graph also yesterday. We also discussed the various roles which are played by the gases. Like for example, we talked about the aerosols. We talked about aerosols, how they can lead to number of phenomena. Very important, they behave as hygroscopic nuclei. We saw that how they can lead to dimming or brightening in the if you talk about in the Earth atmosphere, because they are controlling the transparency of the atmosphere. We also talked about that how through the phenomena of scattering, they are producing different shades in the sky, the blue color shade or the reddish color shade. So all of these we had discussed yesterday. So we also talked about the variable components, including the role of the water vapor. We saw that how water vapor is a very important greenhouse gas, and it is primary factor responsible for, if you talk about the weather phenomena which are taking place in the atmosphere. Okay, so all these things we had yesterday discussed. One thing, if you talk about, we had to discuss was, we also talked about the ozone. I gave an introduction to ozone. I will be talking about that, how layering in the ozone is there in the stratosphere. Then we also talked about the air pollutants. We had to in fact talk about the air pollutants. So another, if you talk about, that is what I'm talking about, Sumit. These are the components that you have to talk about. That is why I gave this PPT, because in PPT everything that we talked about, it is written in very short. इसीलिए मैंने ये PPT दिया था. Okay. So if you talk about another variable component that we had to discuss was the various type of pollutants which are found in the atmosphere. So अगर तुम बात करो pollutants की, तो pollutants, there are basically, what is first thing that you have to understand is that when we are talking about the pollutants which are found in the atmosphere, there are basically two type of pollutants which are found in the atmosphere. First category of pollutants हम उनको बोलते हैं primary pollutants. And second category of pollutants are referred to as the secondary pollutants. You can understand that today India is facing a very big problem of pollution, particularly in the metropolitan cities like Delhi. So Delhi, it is winter time, pollution is so much in news. So there are a variety of type of pollutants which are present in the atmosphere. So if you talk about essentially these pollutants, so can you see these, this is the primary pollutants, and here it is given percentage by weight. So one category of pollutant are nitrogen oxides, various forms of nitrogen oxides. Then if you talk about particulates or carbon monoxide, it is the maximum, the biggest pollutant which is present in the atmosphere. Then there is sulfur oxides, there is volatile organics, and there is particulates, that is, you must have heard about PM 2.5, PM 10. All of these, if you talk about, are the main primary pollutants which are present in the atmosphere. Okay. So if you talk about these pollutants, what is the source of these pollutants? There is another, this pie chart is given, it is also given in your notes. So if you look into this pie chart, you will be finding that the primary source of these pollutants is transportation. It is just average, it can vary from city to city. We are talking about a global average. So here we find that transportation is very, very dominant reason for the presence of these pollutants in the atmosphere. Then there is stationary source fuel combustion, industrial processes, solid waste, and various type of miscellaneous processes which are adding these pollutants into the atmosphere. Various miscellaneous like construction हो सकता है. अगर for example अगर हम दिल्ली के pollution की बात करें, तो as I told you कि everywhere the if you talk about this share will vary. तो अगर हम दिल्ली में बात करें, तो construction activities, if you talk about, they form almost 25% of, they are the reason for almost 25% of this particulate matter which is present in the Delhi's atmosphere right now. And it is, if you talk about it is one of the main reason, but government ने अभी देख सकते हो कि there is a kind of whitewashing going on, a kind of demographic, हमने कल बात किया था कि there is fatigue which has developed, and government is not so much concerned अभी तक भी. If you talk about many measures which should have been taken of the kind of anthropause, वो सब नहीं हुआ है. So again the pollution continues, the situation is very bad. Morning itself I was coming to the class, so I saw it was like very thick smog was present in the atmosphere. Is carbon dioxide not considered pollutant? See, first of all, you will have to understand what is essentially pollutant. So if you talk about pollutants, pollutant is any material which is normally not found in terms of its quantity or presence, but due to natural or anthropogenic factors, it has or it is present, लिखते हैं, it is present in high concentration. High concentration. So any such kind of substance or material, we can call it as pollutant. अब कार्बन डाइऑक्साइड की अगर हम बात करें तो कार्बन डाइऑक्साइड, if you look back in the previous times in the atmosphere, it was very high. Then there was various, जब हमने origin of atmosphere पढ़ा था, so we saw that how carbon dioxide was removed through number of processes, like for example, how carbon dioxide was removed from the precipitation which fell through, then how it was removed by the plants or the species which are performing photosynthesis. So ultimately we saw that the pre-industrial levels, the carbon dioxide concentration was around 280 ppm. Human beings through their activities have improved, increased it to around 420 ppm by now. So in this context, अगर हम जाएं तो definitely carbon dioxide can be considered as a pollutant gas. But the thing is, we have to understand it is a pollutant in terms of higher concentration. Because if you remember yesterday when we were talking about the significance of carbon dioxide, we saw that how carbon dioxide is so much important for the presence of, for the maintaining the average temperature of the earth. Without carbon dioxide, maintenance of this average temperature of the earth wouldn't have been possible. So think about this, if there was no carbon dioxide in the atmosphere, the temperature of the earth would have been around minus 18 degrees Celsius. Neglecting the role which is played by water vapor, it would have been around minus 18 degrees Celsius would have been the average temperature on the earth's surface. You can very clearly understand under such circumstances, life wouldn't have flourished as it has today. Okay. So we are considering carbon dioxide as a greenhouse gas, and these greenhouse gases are causing several type of problems. In this context, they can be considered as pollutants. Okay. But we have to understand it is pollutant in terms of concentration or quantity, not by its very presence. I hope, Janardhan, it is clear. Okay. So that is basically, if you talk about the sources of these pollutants which are present in the atmosphere. Then if you talk about, there is secondary pollutants also. Abhi humne baat kiya. For example, if you talk about here, there is one equation given. Can you see nitrogen dioxide plus volatile organic compounds, when they come in contact with strong sunlight, then what is produced? A pollutant is produced. When ozone is present in the troposphere, it is basically a secondary pollutant. Okay. So what we find, there is presence of ozone. As a result of this reaction, there is formation of ozone. Simultaneously, you will find that there is several other components of smog. So you can see winters are coming, particularly the people living in northern India. We all will be experiencing these dense smogs. So again, that smog is also what? It is also a secondary pollutant. Okay. So that is basically if you talk about the case of pollutants. I hope it is clear. So pollutants are the other, if you talk about important component which are present in the atmosphere. And you know, because of the presence of these pollutants, what can happen? There can be phenomena like acid rain which can take place. So for example, यहाँ पर देख सकते हो कि this is the case of the pH which was measured of the rainfall which occurred in USA in 2003. And you can see particularly the areas. We have seen that this Great Belt region is one of the very important manufacturing belt of US. And if it is manufacturing belt, you can very clearly understand that there will be lots of pollution present in the atmosphere in this area. So you can very clearly see what is happening. The pH, as you go towards the areas which are more industrially developed, the pH is declining. That means the rain is essentially becoming more and more acidic. So there is phenomena of acid rain taking place. Okay. So all of these, if you talk about, are the pollutants which are present in the atmosphere. Okay. So that is about the composition of the atmosphere. Okay. Okay. So if any one of you has to ask any question before ultimately further I continue with the structure of the atmosphere. As I have told you friends that you will see कि ये जो अभी हम क्लाइमेटोलॉजी का जो बहुत बेसिक पार्ट कर रहे हैं, ये फिल्म्स में तुम्हें कितना कॉन्फिडेंस देगा, कितना बूस्ट देगा, यू विल सी. Tell me. Should we start with the next topic, structure of the atmosphere? Comment करो यार. And those people who are watching the class, please hit the like button. Okay. और क्लास अच्छी लगे तो वो धांसू वाले कमेंट्स भी करना, गो टू वर्क टाइप के. Okay. So if you talk about the structure of the atmosphere, Prakash here is asking why in winter the pollution is high. Prakash, we will be coming to this point. Okay. Winter में there is a phenomena which is taking place that is referred to as temperature inversion. Okay. So we have not reached to that particular topic of temperature inversion. When we'll reach there, temperature inversion, I will be talking about the impact of temperature inversion, and there particularly I will be explaining this phenomena of pollution. Okay. Okay. So structure of the atmosphere. Now, अगर मुझे एक phenomena है, suppose there is a phenomena, ठीक है, real world phenomena are very complex, whether living, non-living, whatever, they are very, very complex. Now, if you talk about, if you have to make sense, if you want to understand them, one of the very common tool available to study any phenomena, it is referred to as classification. Tell me, क्या हम classification करके, do we simplify things with classification? Yes or no? When we classify, there is random number of things which are present. These all represent phenomena. And when we classify the phenomena, does it become simple? Does it becomes easily comprehensible? Does it becomes more understandable? Obviously, yes. So same thing when we are talking about the structure of the atmosphere, how the atmosphere looks. Okay. You can understand that different ways can be there to look at the same structure of the atmosphere. Okay. And atmosphere, if you talk about, can be considered like up to 1000 kilometers की height तक atmosphere is present. ठीक है. Although it is not much, if you remember, in the geomorphology topic, tell me, what was the depth at which the center of the earth located? कौन बताएगा मुझे? Who will tell me? Very good, Janardhan. We had seen that it was over 6,371 kilometers. And atmosphere, we are talking about maximum 1,000 kilometers. Okay, maximum I am talking about. Real atmosphere, which is dense, which has strong impact. If you talk about that atmosphere is not very thick. It is, you can say 100, maximum 200 kilometer. The atmosphere which has strong impact, it is present. And उससे भी अगर थोड़ा सा extend करें तो 300 kilometer, which is, you can understand the dimensions up to which the ionosphere, if you talk about, is concentrated. Although ions और भी ऊपर तक मिलते हैं, it is concentrated. ठीक है. So अगर compare करो, if you compare the atmosphere with, if you talk about the interior of the earth, tell me, क्या हम एटमॉस्फेयर को कंपेयर कर सकते हैं ऑरेंज के साथ? ऑरेंज का जो कवर होता है, हैव यू सीन दैट ऑरेंज कवर? सो रेस्ट ऑफ द ऑरेंज is basically what? It is the earth. That thin cover which is there over the orange, that is basically the thickness of the atmosphere. I hope it is clear. Now you have to make sense of how the structure is from the surface of the earth till the end of the atmosphere, how it is. Okay. So can we say that when we are talking about the structure of the atmosphere, we can do here also the same thing, that is, we can use that tool of science and we can try to simplify it. We can essentially try to make sense out of it, and that is referred to as classification. ठीक है. तो अगर मैं क्लासिफिकेशन की बात करूं, you can understand that classification is always on some criteria or basis. तो यहां पर भी हम क्राइटेरिया या बेसिस ले सकते हैं. लाइक फॉर एग्जांपल, कैन वी टेक वन क्राइटेरिया लाइक ऑन द बेसिस ऑफ डेंसिटी, और density is reflective in the pressure that the atmosphere will put. ठीक है. So you can understand that. So average, if you talk about sea level pressure, अगर हम देखें sea level पर, how much of the, despite being very thin, till the atmosphere is able to put 14.7 pounds per square inch of weight. ठीक है. So this pressure is, in terms of pressure, it is around 1013 millibars. ठीक है. But what we find, as you rise with the altitude, can you see here? The altitude is given in kilometers and here pressure is given in millibars. And when I said 100 kilometers or 200 kilometers, can you understand how the atmosphere becomes very, very rare? Particularly as you go above 30 kilometers, it becomes very, and by the time we are reaching 30 kilometers height, can you see that it is, the pressure becomes only 12 millibars. Okay, it becomes only 12 millibars, and further above by 40 kilometers, you can see that it is becoming just 3 millibars. So it becomes very, very rare, very, very less dense. Okay, this graph, you can see that this graph shows how, if you talk about the air pressure in millibars, it is essentially declining. So here, can you see that? Given is the air pressure in millibar, and here we are talking about the altitude in kilometers. So when we are near the surface, it is over 1000. अभी हमने देखा 1013. But as you go upwards in the atmosphere, it will be basically what? It will become very, very rare. I hope this much is clear. Tell me. This is very important. It is very, very important to understand this rarity of the atmosphere with height. ठीक है. Because हम देखेंगे, think करो, voice is breaking. I don't think your voice is fine here. Okay. Is voice breaking for everyone? Okay. I think it is your end problem. Now think करो कि suppose करो कि there is this air. ठीक है, ये एक पार्सल ऑफ एयर है और इस पार्सल ऑफ एयर में देयर आर सपोज these 5 particles of air present. We are just imagining something to understand. Now, think about this. If this air is forced to rise, tell me, can I say it is going from where to where? Is it going from more dense to less dense environment? Yes or no? And if it is going from more dense to less dense environment, इस एयर के साथ क्या होगा? What will happen with the volume of this air parcel? Tell me. What will happen with the volume of this air parcel? Can I say it will expand? You know, this is the property of gases. So essentially what will happen? The volume of this air essentially will expand. ठीक है, and as it expands, you can understand कि ये जो 5 particles हमने बात की है, these 5 particles which are right now in this near the surface, they are near to each other. We will see that distance between them will increase. ठीक है, और हम देखेंगे because of this a very crucial phenomena in the atmosphere is created. We will call this phenomena as adiabatic cooling. I will come to that concept later on. So it will be adiabatic cooling. On the other hand, on the contrary, if suppose an air mass from above is forced to subside, then what is happening? It is going from less dense to more dense region. We will find that it will lead to adiabatic heating. अभी मैं इसको explain करूंगा when we'll talk about the troposphere. Just I am giving a sense of what is the significance of this diagram that we have seen. I hope it is clear. Tell me. So one classification, the first classification of the atmosphere can be done on the basis of its density, on the basis of, if you talk about the pressure which is present. Okay. Then one more classification we had already seen. हमने वो already देखा है, तो मैंने इसमें पीपीटी में यहाँ पे नहीं डाला है. But tell me, have we seen that another classification can be on the basis of can it be on the basis of composition? Who will tell me? When we are talking about on the basis of composition, what are the structures which we find in the atmosphere? What are the structures which we are finding in the atmosphere? Yes, very good, Janardan. We divide the atmosphere into 2 parts. The one which is near to the ground up to 80 kilometer, we saw that we were calling it as the homosphere, because in this part of the atmosphere there is mixing of air taking place and there is a particular composition of the atmosphere found, excluding the variable components. That means of the dry air. We yesterday talked about the concept of the dry air. Above that, we will see that there is presence of heterosphere. Okay, so we have seen that from the surface to up to the height of 80 kilometers, there was presence of the homosphere, and above that there is presence of what you call it as the heterosphere. Okay. Even within the heterosphere, if you talk about, you will be finding that there is a particular structuring of the air which is found. So within the heterosphere or within the heterosphere, we find that the air is not mixed like it is there in the lower frictional layer. It is not mixed. Here we find that the layer of atmosphere, the atmosphere layering is more like stratified. Okay. So if you talk about in the lower part, you find that there is more presence of nitrogen. Above that, if you talk about, there is oxygen. Above that, there is presence of helium, and the lightest one, hydrogen, is present at the top. Okay. So that is what we find in the composition of the heterosphere. Particularly अगर हम बात करें तो ये जो ऑक्सीजन और नाइट्रोजन यहाँ पर हमें मिल रहे हैं, these are not found in molecular form, they are particularly found in atomic form. ठीक है. There will be, you can understand, थोड़ी मिक्सिंग होगी, यहाँ पर भी कुछ ऑक्सीजन मिलेगा, ठीक है, और यहाँ पर भी कुछ नाइट्रोजन मिलेगा, particularly in the lower part. It is around from here above 200 kilometers. Atomic oxygen dominates, and atomic oxygen continues to dominate up to around, if you talk about, somewhere around 400, and beyond that, if you talk about, there is more concentration of helium and hydrogen which is found. Okay. So as I had told you yesterday, can you understand that this type of sequence, this type of layering, this type of structuring, it is outcome of what? Why it is this kind of like this structured? कल भी हमने बात किया था. Who will tell me? Why it is structured like this? Yes, it is related with the mass, okay, atomic molecular mass which is there, and because of that, if you talk about, they are arranged in this fashion. So this is also the structure of the atmosphere. This is one way of looking at the structure of the atmosphere. Then third way of looking at the structure of the atmosphere is on the basis of vertical temperature distribution. Okay. On the basis of the vertical temperature distribution. And if you talk about on the basis of vertical temperature distribution, we find that this is the kind of structure which is found in the atmosphere. So this is the thermal structure of the atmosphere. So if you are near to the surface, what will happen? We find that as we go upwards, first there is decline in the temperature within the atmosphere. Okay, we will see, we will call it as the lapse rate. So there is a lapse rate applicable within the lower part of the atmosphere. Somewhere in between the height of, if you talk about around 8 to 18 kilometer, there you will find that this decline in temperature, what happens to it? It is arrested, and now the temperature remains what? It remains same. So isothermal conditions would exist. But somewhere, if you talk about, if you leave that lower part, that is above 15 kilometers, as soon as you go above 15 kilometers, you find that the temperature again begins to rise. तो अगर मैं इसको नोटिस करूं, तो as I am going from the surface, as I reach to this zone, which can range, as I told you, this can range between 8 to 18 kilometers. It will depend upon which latitude we are. So can you see that here the temperature can decline? In fact, this is happening more near the equator. Can decline almost, ये actually सही से बना नहीं है, but it is more like -60 डिग्री सेल्सियस. जो मैंने नोट्स दिया है उसमें ये डायग्राम ज्यादा बेटर बना हुआ है. जस्ट लेट मी यूज दैट डायग्राम. यस, कैन यू सी हियर? तो एक एवरेज अगर हम 10 किलोमीटर का ले लें तो कैन यू सी टिल 10 किलोमीटर व्हाट इज हैपनिंग? The temperature is declining. So can you see very low temperatures, that is -60 degree Celsius temperature तक reach हो जाता है. After that there is an isothermal condition exists, and somewhere around after 15 kilometers you will find that the temperature begins to rise, and within after some height around 50 kilometer it keeps on rising. Then again there is isothermal, there is no change, but after some distance further, after some height further, it begins to reduce. Can you see that? And when you reach somewhere around this height of 80 kilometers, lowest temperature in the atmosphere are found. So this lowest temperature, can you see? It is around -90 degree Celsius. ठीक है, विच इज द लोएस्ट टेम्परेचर विच आर रजिस्टर्ड. इससे भी लो रजिस्टर हुए हैं, ठीक है, बट एट द सेम प्लेस विच वी आर टॉकिंग एट द सेम हाइट. बट एवरेज ये यहां पर -90 डिग्री सेल्सियस का टेम्परेचर हमें मिलता है. देन एज यू गो फर्दर अपवर्ड्स यू फाइंड दैट देयर इज अगेन आइसोथर्मल कंडीशंस, बट टेम्परेचर बिगिंस टू राइज अगेन. ठीक है. So this is the distribution of temperature within the atmosphere with height. अब मुझे एक चीज बताओ, एक सिंपल सा अभी जो हमने बात की उसको थोड़ा सा देखते हैं एंड समझने की कोशिश करते हैं कि आइडियली होना क्या चाहिए. ओके, अगर सपोज करो कि यू आर डूइंग सम फिजिकल एक्टिविटी, ओके, लाइक वन फिजिकल एक्टिविटी कैन बी कि अगर मैं किसी को, इफ आई स्लैप समवन, व्हाट विल हैपन? टेल मी, इफ आई स्लैप समवन व्हाट विल हैपन? कैन वी से इफ यू स्लैप समवन विल देयर बी प्रोडक्शन ऑफ हीट? क्या हीट प्रोड्यूस होगी उससे? अगर तुम्हें कोई थप्पड़ मार दे तो क्या तुम्हारे गाल लाल हो जाएंगे? टेल मी, विल योर चीक्स बिकम हीटेड? So when work is done, what will happen? There will be heat produced. It is as simple as that. Okay. So tell me, when these two, or when this, in this scenario, when these 5 particles of air were near to each other, what will be the chances that they will keep colliding with each other? What will be the chances that they will keep colliding with each other? Tell me, will it be high or low chances? Obviously, the chances will be high, and that will in fact happen. They will keep colliding with each other. So if they keep colliding with each other, same that slap, remember, what will be happening? Can I say heat will be produced because work is being done? So there will be production of heat. Okay. So when you are near to the surface, what is happening? There is lots of collision between the particles taking place because they are so much near to each other. And because of that, the temperature near the surface will be what? The temperature near the surface will be higher. But what will happen? If we go upwards in the atmosphere, What will happen with the density now? Density is reduced. You can see here I have shown what is taking place. These particles have moved away from each other. Now tell me here at this height, what will be the chances of collision between them? Will it be higher than on the surface or lower than on the surface? The chances of collision. It will be definitely lower than the surface. So tell me, does it means that as I am going upwards, there is less collision, and less collision का मतलब क्या है? Can we say less collision means that there is less work done, and if less work is being done, this means what? This means that there will be less heat produced. ठीक है? And heat, if you talk about the degree of heating, is measured through temperature. So can I say on the surface, because of this structure of the atmosphere, should we be finding that near the surface the temperature should be? So let us talk about this point. So I am going to tell you now two very important principles of climatology. So you can even note it down. Two most important principles of climatology. So the first very important principle of climatology is what? That temperature or reduces with height as the atmosphere becomes less dense, or we can write it as the atmosphere density declines with height. Declines with height. Then if you talk about second, very important again, is temperature also declines with height because एक और रीजन हो सकता है, अभी मैं सेंटेंस को कंप्लीट करूंगा. Tell me, what will happen as I go from surface to upwards? You know कि heating के तीन mechanism होते हैं. Tell me which are the three mechanisms through which heat is transferred. Which are the three mechanisms through which heat can be transferred? Anyone? Or should I write? So there are three mechanisms. First, very important, is radiation. Radiation. Second, very important, is what you call it as conduction. And third, very important, is convection. So radiation, conduction, and convection. I hope you know the difference between these three. What is the difference between these three? What is happening in case of radiation? Tell me. Can we say in radiation there is no medium needed for heat transfer? So there is no medium needed for heat transfer. for heat transfer. Then if you talk about in conduction, medium is needed for heat transfer. In case of convection, what is happening here, also medium is required, because the medium itself rises and transfers the heat. So here what we find, that medium itself transports the heat. ठीक है, तो तीन तरीकों से होता है. अब ये तीनों तरीकों से अगर हम देखें तो वन थिंग दैट विल कम टू आवर नॉलेज, दैट as you go upwards in the atmosphere, ठीक है, temperature will decline, because बहुत ही इंपॉर्टेंट प्रिंसिपल है, atmosphere is mainly heated from below. ठीक है, हम बाद में देखेंगे जब अभी इंसोलेशन पढ़ेंगे तो वी विल सी कि द इनकमिंग सोलर रेडिएशंस, ठीक है, दे आर प्राइमरली इन व्हाट, दे आर प्राइमरली इन द शॉर्ट वेवलेंथ ऑफ द स्पेक्ट्रम. And because they are in short wavelength of the spectrum, atmosphere is largely transparent to the incoming solar radiation. When this incoming solar radiation reaches the Earth's surface, it heats the surface. Then what happens? From the Earth's surface, there is terrestrial radiation, which are long wave radiations are produced, and atmosphere is able to ultimately catch these radiations. In fact, not only because of radiation, very important is the phenomena of conduction in this heating. ठीक है, तो कैन यू अंडरस्टैंड कि अगर सपोज करो कि अर्थ का सरफेस हीट अप हो गया, what will happen with respect to the transfer of heat upwards? Will it be uniform, or the transfer of heat will decline as we move upward? This transfer of heat will decline as you move upwards. Okay, why it will decline? Very primary reason for this decline is what it is, that atmosphere or air is a poor conductor of heat. Okay, so air is essentially what? A poor conductor of heat. So tell me, can I say that conduction as takes place of heat upwards, particularly in the troposphere, will there be less and less conduction of heat? Tell me yes or no. This is about the conduction of heat. I hope it is clear. Because why? Air is poor conductor of heat. Okay, so conduction of heat reduces with altitude because air is poor conductor of heat. Air is essentially a poor conductor of heat. ठीक है, so can we say इसके बेसिस पर हम एक conclusion पर पहुंच सकते हैं? Can we reach to a conclusion and can we say that atmosphere is mainly heated from below? ठीक है, atmosphere is mainly heated from below. So the second principle, if you talk about, temperature also declines with height, because we can write it here now, because the atmosphere is mainly heated from below. Tell me, are we clear with these two most important principles of climatology? Okay. Now, अगर ऐसा है, if it is there like this, tell me, ideally, if suppose we are talking about this is altitude and this is, if you talk about temperature, what type of graph should we expect in the atmosphere on the basis of those two principles we talked about? Can I say expectation should be that the temperature should continuously decline with altitude? Yes or no? क्या कुछ ऐसा ग्राफ होना चाहिए of the temperature? Should it be like this? Should it look like this? Tell me fast. On the basis of the two principles that we have talked about, should it look like this? It should look like this. Ideally, it should have been like this. ठीक है? इस फिनोमेना को हम क्या बोलते हैं? We call it as the lapse of temperature. ठीक है? We call it as the lapse of temperature. So ideally what should have been? Temperature should have declined with altitude, that there, in other words, there should have been regular lapse of temperature with altitude. But tell me, हमें क्या मिल रहा है? ऐसा zigzag, उल्टा पुल्टा problematic सा scenario मिल रहा है. Can you see that? So much complex temperature distribution, vertical temperature distribution is found. There is, अगर मैं इसको क्लासिफाई करूं, if I classify it, let us simplify and classify it. Do we find that actually something is like this? We are finding, suppose this is the surface and this is the atmospheric column. So if you talk about, we find that somewhere एक average height जो हमने ली थी, if we take that average height of 10 kilometers, this height was 10 kilometers, then we saw that another height was around 50 kilometers, then another height was 80 kilometers, and then above that, so this is the altitude, and here if you talk about is the temperature. So what exactly we are finding? We are finding is that something, if you talk about, is like this. पहले टेम्परेचर डिक्लाइन हो रहा है और ये डिक्लाइन होकर के कहां तक पहुंच जा रहा है? इट इज रीचिंग अप टू दिस -60 डिग्री सेल्सियस. But after that we find that there is, it remains same for some time, then it begins to decline. Then it begins to, increase. So we are finding that then it begins to increase. And if you talk about, it increases here when it reaches, it is almost reaching, if I give number to it, it is almost reaching to 0 degree Celsius. You can understand 0 degree Celsius is higher temperature than -60. तो ये 0 डिग्री तक पहुंच जा रहा है. Then what is happening? Again some isothermal, but again it begins to decline. Now there is more steep decline taking place and it reaches up to here. If I give number to here, average it is -90 degree Celsius तक पहुंच जा रहा है. Then if you talk about after that, again some isothermal, condition, what is happening? Again, it begins to rise. Okay, and it can keep rising. Theoretically, it can reach over 1200 degrees Celsius. Okay, so it keeps on rising as you go toward the end of the atmosphere. So this is the kind of structure which we are finding. अब मुझे ये बताओ कि अब मैं इस स्ट्रक्चर को अगर डिफाइन करूं तो टेल मी, आर वी फाइंडिंग फ्यू पैटर्न्स हियर? लाइक टेल मी, are we finding that there is one layer where there is application of lapse rate? Yes or no? Is there in the lower layer, do we find that there is lapse rate applicable? Tell me fast. Then above that, do you find that there is isothermal conditions which are found? उसके ऊपर जाते ही कैन आई से नॉर्मल जो होना चाहिए, नॉर्मल क्या होना चाहिए? व्हाट शुड बी द नॉर्मल? देयर शुड बी लैप्स ऑफ टेम्परेचर, दैट शुड बी द नॉर्मल. बट कैन आई से इट इज अगेंस्ट द नॉर्मल? इज देयर रिवर्सल टेकिंग प्लेस? यस और नो? इज देयर रिवर्सल टेकिंग प्लेस? तो इस रिवर्सल को हम बाद में देखेंगे जब नॉर्मल से टेम्परेचर, ideally it should be lapse of temperature, but when it reverses, ठीक है, we call it as temperature inversion. Okay, then again there is, can you see there is isothermal conditions are found, but after that again there is the lapse of temperature is taking place. A layer is found in which lapse of temperature is taking place. As I go upwards further, again I find that there is some isothermal conditions, but beyond that, till the end of the atmosphere, do we find that again there is a temperature inversion layer which is found. Are you able to visualize this? Tell me. ठीक है, अब मुझे एक चीज बताओ कि क्या मैं इस कंक्लूजन पे पहुंच सकता हूं कि कैन आई रीच टू दिस कंक्लूजन दैट atmospheric structure on the basis of temperature can be identified on the basis of temperature? Atmosphere has layered structure, and in this layered structure, tell me, can we say that there is two layers displaying lapse of temperature? Then second, can we say two layers displaying inversion of temperature? And can we say there are three transition zones between these layers showing isothermal characteristics or traits? Is my conclusion correct? Tell me. looking at how the temperature is changing vertically, is my conclusion correct here? That there are two layers displaying lapse of temperature. There are two layers displaying inversion of temperature, and there are three transition zone in between these layers. The boundaries of these layers तीन जगह पर बन रही हैं. Three places the boundaries are formed, transition zones are formed, where you find isothermal traits. There is no change. That means there is no increase or decrease in temperature taking place. On the basis of that, can you understand what we are doing? We are naming these layers and these transition zones. Can you see here the names which are being given to these transition zones? So the lowest most layer, we are calling it as what? We are calling it as the troposphere. The boundary, its upper boundary which forms the transition zone, we are calling it as the tropopause. Then above that we are going where there is increase of temperature taking place, we are calling it as stratosphere. Then if you talk about in this, at the upper limit of the stratosphere, another boundary or transition zone is existing. We are calling this transition zone as stratopause. Then above that, that lapse of temperature layer, second lapse of temperature layer we are finding. So we are calling it as mesosphere. We are naming it differently, mesosphere, middle layer. Because can you see it is in a way transition between this thermosphere and this stratosphere. So it is the middle layer. It is the transition zone layer between these two. So we are calling it as the middle layer. Its upper boundary is referred to as mesopause. Again, wahan par bhi we are finding there also isothermal conditions. Always in transition zones we are finding isothermal conditions are existing. And then the temperature increases. The second inversion layer is found at the top, and this is what we are calling it as the thermosphere. Are we clear on this? Tell me. ठीक है, इसमें किसी को कोई भी कंफ्यूजन हो तो पूछो फटाफट. Remember, climatology is step by step. If you miss any of the steps, it will be very difficult to understand the advanced things which will be coming. Okay, so that is how these various, if you talk about structures, are recognized. Now there are, why does isotherms occur? I will come to that, Janardhan. Abhi I will be explaining. Okay, just wait for it. There is a time when it will come. Okay. Now, within these layers also, you can find that some places a sub-layer can be found. Can you see in this diagram, there is, within the stratosphere, there is written maximum ozone. Can you see that? Somewhere around, can you see it is between 20 to 30 kilometer के बीच में, there is maximum ozone present. So, because there is so much concentration of ozone in this layer that we call this layer as also ozonosphere. We are calling it as the ozonosphere. Are we clear on this? Tell me. Ozonosphere. So you have to be very clear, ozonosphere is not a separate layer. It is part and parcel of the stratosphere. Then as we go into the thermosphere, we will be finding, because here they have written only up till 140 kilometer. But if I go in the thermosphere, what I will be finding, so thermosphere's boundary is 80 kilometer, and we don't exactly know where is the end of the atmosphere. Let us say I am drawing broken lines. Let us say it is 1000 kilometers is the boundary. So this layer is your thermosphere. Okay. Now we will see that within the thermosphere also two sublayers can be found. It is further divided into two sublayers. Up to, if you talk about a height of about 600 kilometers, the lower part of this thermosphere, there is high concentration of ions found. So this part is referred to as ionosphere. Okay. And if you talk about above this, the atmosphere becomes very rare, hardly exists. It is more, can you understand? There is more probability that if you go in Antarctica, you can find a person. That is more probable than if you go in this upper part and you find a particle of air. It becomes so much rare. So this, if you talk about, is referred to as the, because it is the external bound part layer, it is also referred to as the exosphere. So thermosphere is further divided into two parts, subparts, ionosphere and exosphere. Tell me, is this structuring clear to all? And when I'm using the word clear, clear का मतलब है what is clear. I am not still talking about why. I've still not come to why. Okay. So that is if you talk about the structure of the atmosphere. So once we have made a mental image of how the structure of the atmosphere looks, now we can one by one we can look at each of the layers of the atmosphere. So first, let us start with our first layer, that is the troposphere. Troposphere. ठीक है. So अगर मैं troposphere की बात करूं तो actually this troposphere comes from a Greek word. ठीक है. It comes from a Greek word. It is tropin. And what is the meaning of this word tropin? It means turning or mixing. It essentially means turning or mixing. So can you understand within the troposphere why we are calling it as troposphere? Because in the troposphere, you know, most of the weather phenomena are taking place where? In the troposphere. So there is constant turning, there is constant mixing, there is lots of turbulence which is present in the troposphere. So what we are finding, there is constant turbulence and mixing taking place in the troposphere. Okay, in the troposphere. So that is if you talk about the troposphere. If you talk about if you atmospheric mass के हिसाब से देखें, if we look at from the perspective of atmospheric mass, troposphere contains almost 75% of total atmospheric mass. And as we said before, almost all weather phenomena occur in the troposphere. Almost all the weather phenomena are occurring in the troposphere. So, can you understand that I'm using the word almost all the weather phenomena? I'm not saying all the weather phenomena are occurring in the troposphere. Okay. And one more thing of the troposphere is almost more than 99% of water is contained in the troposphere. In fact, sorry, water लिख दिया मैंने, water vapor लिखना चाहिए. Water vapor is contained in the troposphere. So these are some of the broad highlights of the troposphere that you have to understand. Okay. Now, one very important thing that we have seen in the troposphere from the perspective of temperature, that in the troposphere, temperature declines with altitude. Temperature declines with altitude. Okay. Now, this decline can vary from place to place. So, we are saying that this rate of decline can vary from place to place. Okay. So, this rate of decline is referred to as what? It is referred to as environmental lapse rate. It is referred to as the environmental lapse rate. Okay. However, if we take out average of this decline, एक average mean की बात करें, remember, did we saw that climatology or climate is study of means? Yes or no? So if you talk about a mean of this, mean for the whole earth or whole atmosphere, if we talk about, it is at the rate of 6.5 degrees Celsius per kilometer. Okay. This rate is referred to as the normal lapse rate. It is referred to as the normal lapse rate. I hope it is clear. Tell me. And very importantly, can you see that many times we use these two terms interchangeably as synonym of each other? To some extent they are also, but can you see the technical difference between the two terms? Environmental lapse rate क्या है? It is the actual rate at which temperature declines with altitude within the troposphere. While what is normal lapse rate? It is the mean, which is always considered at what? 6.5 degrees Celsius per kilometer. I hope it is clear. Okay, so tell me, just think about this. Suppose there is a surface which is very cold and there is a surface which is warm. Okay, and there is, as you go upwards, what is taking place? There is, atmosphere is becoming less dense. heating is getting reduced, all those things are taking place which we talked about. So tell me one thing, that can we say that here I'll give you two scenarios. You will tell me which one is correct, A or B. When the surface is very cold, the lapse rate, here we are talking about temperature. So the lapse rate will be more like this, or the lapse rate will be more like this. Which do you think is more probable, A or B? Can you understand? Here we are talking about the altitude. Which do you think is more probable, A or B? Only two people are answering. Why? Where are others? Correct answer here is, it will be A. Okay. It will be A. So if the line is more vertical, less slant, it means that the rate of decline of temperature is lesser. So can you imagine कि when there is cold surface, already cold है ना ये surface, तो अगर मैं if I am going little above, temperature change is not so much felt because the surface, can you understand, it is still cold. So the rate of change here will be what? It will be lesser. But if you think about this warm surface, can you understand that as you go upwards, does it means that the change in temperature or decline in temperature will be more faster? Will it take place at more faster rate? So this diagram is actually applicable to here. I hope I am clear on this. Are we clear on this? So can you understand the difference between environmental lapse rate and the normal lapse rate? The environmental lapse rate is the actual lapse rate, and you can understand that it will vary from place to place, while normal lapse rate is essentially what? It is the mean. Also you can understand, इसको हमने already बात कर लिया, but यहाँ पर देख लेते हैं फिर से एक बार. We have already talked about, just let us revisit it. So cause of environmental lapse rate. What is the cause of environmental lapse rate? Two primary causes, if you talk about, are, one is decline in density of air or atmosphere with altitude. Second is atmosphere is mainly, I'm using the word mainly, I'm not using the word only, is mainly heated from below. So these are the two most important causes of why there is presence of this lapse rate. But because you have to prepare for prelims also, so you can understand other causes भी हम बात कर सकते हैं. ठीक है? Tell me, can we say one important cause will be, what is happening with the amount of water vapor as you go upwards? what will happen with the amount of water vapor as you go upwards within the troposphere? Will it increase or decrease? It will reduce. No doubt it is going to decrease. Okay. So if have we talked about that water vapor is a very important greenhouse gas? So can you understand that as you go upwards, the temperature will also decline because there is decline in the water vapor concentration. Okay, so there is another we can talk about is there is reduction in concentration of, rather than just writing water vapor, we can say greenhouse gases. They are also reducing as you go upwards. I hope it is clear. Tell me. So that is the environmental lapse rate. इसमें किसी को कुछ पूछना है तो पूछ सकते हो, because as I told you, these are the two most important, two most fundamental laws of climatology, the first two. As a student जब मैं प्रिपेयर करता था एग्जाम के लिए, तो many times I got stuck in understanding of some concepts. Then I would always do one thing, I'll revisit the principles of climatology. And so many times it happened, as soon as I revisited these two, I would solve that complex problem. Okay, so that is, if you talk about the very important thing about the troposphere. Then another thing, let us little bit more talk about the water vapor which is present in the troposphere. So हमने देखा है कि water vapor concentration declines with altitude. So as I have told you before also, 6 kilometer की height तक 90% of the water vapor is present. ठीक है, and by the tropopause, that is the boundary, you will find that 99% of the water vapor is present. Okay, and because of this presence of water vapor, have we seen that because of this reason, practically almost all the weather phenomena occur in the troposphere. Practically almost all the weather phenomena are occurring in the troposphere. Yesterday when we were talking about the significance of water vapor, I had explained you how water vapor plays very important role, the dominant role, the most important role in weather phenomena. Okay, that is one. Then next, troposphere mein one more very important concept we have to learn. But before that, let me explain you a few things. And let me ask you, suppose we are talking about a balloon. Okay, we are talking about a balloon, and suppose karo the temperature of this balloon is 10 degrees Celsius, while the surrounding air which is present there, the temperature is, let us assume it is 8 degrees Celsius. What will happen with this balloon? Tell me fast, what will happen with this balloon? You can call it as balloon or you can call it as the parcel of air, whatever. If the temperature of this balloon or parcel of air is higher than the surrounding air temperature, what will happen to it? Can I say that will it rise upwards? obviously it will rise upwards. ठीक है, तो सपोज ये यहां तक पहुंच गया, एक पर्टिकुलर हाइट तक पहुंच गया, ओके, एंड let us assume that it has reached to a height of 2 kilometers. Okay. Now we find that here the temperature has become minus 4 degrees Celsius, while the balloon temperature has become 0 degrees Celsius. Now what will happen to it? Now what will happen to this parcel of air or the balloon? It will essentially keep on rising because it is still warmer and thus still lighter and still thus it is buoyant than the surrounding air. Okay. Suppose we are talking about this is your boundary of the troposphere. Suppose we are talking about tropopause. So what is the temperature near the tropopause? अभी हमने देखा था. What is the temperature reached near tropopause? We have seen that here it becomes minus 60 degrees Celsius it becomes. And if you talk about the balloon temperature is now here minus 55 degrees Celsius. Okay, minus 55 degrees Celsius. Let me just make one modification. And what is this modification I want to introduce is, because we have seen that as we are going upwards, we are going from more dense to less dense region की तरफ जा रहे हैं. We are going like this. So what will happen with the size of this parcel of air or balloon? Will it keep rising? Will it keep expanding? Tell me. Will keep expanding because the atmosphere is becoming rare and rare. And हमने क्या देखा था? If it is expanding, what will be the chances of the particles getting collided with each other? It will reduce. So its own temperature will also keeps on declining. So that is why यहाँ पर there was decline of temperature took place. 10 degree Celsius से घट के कितना हो गया? It reduced to 0 degree Celsius. Then here when it has reached to this height of the tropopause, now it has further expanded because here the atmosphere has become even more rare. And here we are saying that it is becoming minus 55 degrees Celsius. Tell me, till here, is it clear? Tell me fast. So can we say till here, there is no problem, it will keep on rising? Yes or no बोलो यार. So till here there is no problem, it will keep on rising because it is warmer and buoyant than the surrounding. But tell me what happens at tropopause. What was the temperature condition at the tropopause? Did we saw that at the tropopause the temperature ceases to decline? Temperature stops declining. Above that, it also begins to increase. Do you remember that? So, as I am going further upward, in this tropopause and the lower stratosphere, we are finding temperature remains here, minus 60 degrees Celsius. As I further go upwards, the temperature can become now here, minus 40 degrees Celsius, because it is now increasing. Remember, We had seen that it was like this was the temperature curve. What about this balloon or this parcel of air temperature? Can I say it keeps on going upwards in thinner, in less dense atmosphere, so it will keep on expanding. So now if it is suppose reaching here, it will expand more because it is now going to more rare atmosphere. So if it has expanded more, tell me, now its temperature has become how much? Suppose we are saying its temperature has become minus 62 degrees Celsius. Minus 62 degrees Celsius. I hope you are getting my point. So tell me, now will it be able to rise? Will it be able to rise beyond the tropopause? Surrounding atmosphere में decline बंद हो गया. Now it has stopped. Within that parcel of air, it is keep expanding and thus the decline continues in it. So tell me, will it still continue to rise or the rise will stop? The ascent will stop. The ascent will stop. So the thing is, here we come to a very, very important, third very important principle of climatology, and that is what? That tropopause. It practically behaves as a lid over the troposphere. It is like a lid over the troposphere. Okay? Which is the limit of upward convection in the troposphere, which is the limit of upward convection in the troposphere. That means अगर air rise हो रहा है, what we are trying to say is something like this, that if suppose from this surface there is a parcel of air, it continues to rise upward, what will happen? There will be a limit of tropopause. Tropopause will not allow this air to further rise. Tell me, are we clear on this point? So it restricts vertical or upward convection within the troposphere. ठीक है? So this is a very, very dominant process. अब मुझे बताओ इसका एक इम्पैक्ट देखते हैं. Suppose we are talking about how it is impacting. So suppose हम point A की बात करें. We are talking about point A, and suppose in point A, air is coming from all direction. When air is converging from all directions, what is we call it as? We call this convergence zones as, बाद में देखेंगे when we study pressure, we call such situations as low pressure. ठीक है? Why? Because when the air will converge from all direction, can I say the air has no other place to go but to rise? Yes or no? ऐसा तो है नहीं कि it will dig in the ground and go downwards. It cannot do so. Air is not so much powerful. So the only place for the air to go is where? is to rise upwards. So this air will rise upwards. ठीक है, but tell me till which height it will be able to rise upwards. This air will be able to rise upwards only till tropopause. At tropopause, as soon as it reaches the tropopause, it is the limit of upward convection, upward rise. So tell me now what will happen with this air, because niche se from below the air keeps on coming. So tell me, can I say here, could we find that this air will be forced to diverge? Yes or no? Will this air forced to diverge? It will. And thus, जहां पर भी we will see later, wherever there is divergence taking place, उन places को हम क्या बोलते हैं? Like here we said it is what? Low pressure. Such places will be referred to as the high pressure. ठीक है? I hope it is clear. Similarly, suppose there is convergence taking place in the upper atmosphere. There can be places jahan par air can converge. So there is convergence taking place in the upper atmosphere. ठीक है? So if there is convergence taking place in the upper atmosphere, again उस convergence को क्या बोलेंगे? We will call it as the low pressure. So now this air which is converging in the upper atmosphere, we know that it cannot go upwards because tropopause is not allowing. Tropopause is very, very adamant. It doesn't allow the air to rise. So tell me, does it means that in this case, the air will have no choice but to side downwards towards the surface, and as it reaches towards the surface, again the ground will behave as the lid and it will have no choice to diverge, but to diverge. So what will be taking place here? We will be finding that there will be a high pressure. Divergence is high pressure, convergence of air is always low pressure. Can you see a pattern here? So always, because of this lid of the tropopause, what it does, presence of this lid leads to development of opposite pressure systems in the upper atmosphere compared to the surface. I hope I am clear on this. ये बहुत बार आएगा. This will come so many times in climatology. It is very important. So I am calling it as the third most important principle of climatology. Tell me fast. Are we clear on this? The lid of tropopause and its impact. Okay, let us move on further. And if you talk about another thing that we need to know is about the height of tropopause. Okay. So if we talk about the height of the tropopause, suppose this is the column of air. We are here talking about poles, and here we are talking about the equator. Here is, if you talk about the altitude. So at the poles, the height of the tropopause is 8 किलोमीटर. Actually it varies, 8 से 9 किलोमीटर के बीच में होता है. ठीक है. So season to season vary करता है. Winters में, if you talk about it, will be 8 kilometers. In summers it can rise little bit upwards, but एक average हम मान लेते हैं 8 kilometers है. At the equator, it is it would become 18 kilometers. So this is the height of the tropopause. This is your tropopause. So the height of the tropopause is not uniform. It varies with latitude. Okay, it is varying with latitude. If you talk about the height of the tropopause in the middle latitudes की अगर मैं बात करूं तो लिख लेते हैं इसको भी. In the mid latitudes, the height can be around, it will vary from 10 to 12 kilometers. 10 to 12 kilometers in the middle latitude. Okay. So the height of the tropopause varies. Now the question is, it is, we are saying varies with latitude. Question is why it varies with latitude. The answer is because the height of the tropopause is determined by the heating from below. Okay, and related convection. So tell me, think about this. One surface is cold and one surface is warm or hot. Tell me, can I say the air present here, will it be heated because of the warm surface? Yes. So will this air will have tendency to rise upwards? Obviously, yes. When you are at cold surface, the surface is very cold. As a result, the air will also, remember, air is always heated from below. Okay, so air, not always, air is heated from below. So here, can I say the air will also become cool, and such kind of cold or cool air, will it be heavier? Yes. So its tendency will be to do what? Its tendency will be to subside downwards. Okay. So in this case, tell me, the air which is present in the troposphere, it is rising up to this height. Here it is not so much. So can you understand the height of the tropopause? Tell me yes or no. So that is how the height of the tropopause is variable. Now based on this, tell me, within the tropopause, which place or point will have lowest temperature? Which place or point will have the lowest temperature within the tropopause or within the troposphere, sorry. Where the lowest temperatures would be registered within the troposphere? Okay, the lowest temperatures in the troposphere are registered in the tropopause. Okay, and if I make here about these lowest temperature, the tropopause which is located at the equator, above the equator, where the height of the tropopause is maximum, here the temperature which is found is almost minus 80 degrees Celsius. In the middle latitudes, we have seen here the height of the tropopause is 10 to 12 kilometers. here you find that the temperature is that average which we talked about there, minus 60 degrees Celsius. At the poles in the tropopause, the temperature is minus 50 degrees Celsius. The temperature distribution is something like this. Okay, I hope it is clear. Can you understand why it will be so? Why it will be so? So lowest temperatures are not found at the poles. Lowest temperatures are found in the troposphere above the equator. Okay. Can you understand? It is very simple. Lapse rate will operate in which of these places for longer distance? Lapse rate will operate in which of these three places for longer distance? Obviously at the equator. Can you see here it is 18 kilometer. So एक एवरेज लैप्स रेट की वैल्यू ले लो. Take average value of the lapse rate. Suppose you take 6 degrees Celsius एक average lapse rate if you have taken. So can you understand? Multiply 6 by 18. Multiply 6 by, here even if you take upper limit to be 12. Multiply 6 by 8. I hope you get my point. ठीक है, जनार्दन इतना नहीं होगा. As we are saying, that is maximum which I have written, minus 80 degrees Celsius, still there it has been registered. I hope it is clear, Prakash. So because of this, there is lowest temperature in the troposphere are found where? In the tropopause above the equator. Is tropopause isotherm? Isotherm क्या होता है? Who will tell me what is isotherm? What is isotherm? Here Himanshu is asking, is tropopause isotherm? Isotherms are imaginary lines joining places having same temperature. ठीक है, कीवर्ड क्या है? Imaginary lines. Now tell me, is the tropopause imaginary to you? Or we do find that there is presence of this boundary. It's very clearly presence of this boundary. It is not imaginary. It is not isotherm. Tropopause में isothermal conditions are found. Tropopause is basically what? Tropopause is the boundary, the transition zone. Okay, so that is if you talk about the phenomena which is taking place, so it is related with the height of the tropopause. Okay, then one more thing. Remember, we said that tropopause is what? It is the lid above troposphere. It behaves as a lid above the troposphere. It behaves as a lid over the troposphere. Now tell me, अभी मैंने तुमको एक इंफॉर्मेशन दी थी that 99% of the water vapor is present in the troposphere, but 1% of the water vapor is present where? In the stratosphere, and some is also in mesosphere. Okay. So there is some water vapor still present in stratosphere and even in mesosphere. It can reach up to mesosphere. So that means, tell me कि ये water vapor कहाँ से आया होगा? From where this water vapor would have come into the stratosphere and mesosphere? We have seen that water has come from where? It has come from inside the earth. So that means this water would have also come from the surface, this water vapor. If tropopause is breaking all, it is like a lid. It is stopping every convection, then how the water vapor will reach? Tell me, how it is possible? If tropopause is behaving as a lid, how this water vapor will reach? There is sometimes there can be breaks in the tropopause, can be caused because of very strong upward convection. Because of very strong upward convection, sometimes this lid can actually break. Okay, so think about this. Suppose we are talking about 20 degrees Celsius. Celsius बोल रहा हूँ, latitude, sorry, 20 degree latitude. And think about this, that there is a very strong cyclone. Very, very strong cyclone is present. And tell me, this cyclone is so much strong. Is it possible that if it is too much strong, is it possible that it can break through this tropopause lid? Tell me, क्या ऐसा हो सकता है? Is it possible? या देखो, क्लाइमेटोलॉजी में तुम लोग अगर मुझे आंसर नहीं करोगे, इफ यू पीपल वॉन्ट आंसर मी रेगुलरली, देन मजा नहीं आएगा. Particularly when the classes are online, can you understand? You don't see the faces of students. As a teacher, I don't feel satisfied. So can you understand that what will happen? Sometimes this lid can do break. Okay? And thus material from the troposphere can be transferred in the upper layers. I hope it is clear. Another thing, like, is it possible that यहाँ पर तो मैंने साइक्लोन की बात की. I talked about a cyclone. Tell me, is it possible that the same thing can be done by a very violent volcanic eruption? Can a very violent volcanic eruption accomplish the same task? It can throw this material so much with force that it can break through the lid of the tropopause. Yes, it can do. Okay, and this is how you can understand that water vapor, if you talk about, can reach into, if you say, into the stratosphere. And not only water vapor. You must have heard about, have you read about, or have you heard about ozone loss of ozone in the ozonosphere? We will see that there is a component referred to as halogens. These halogens are doing what? They are playing very important role. Okay? But these halogens, if you talk about, they are man-made. So how they are reaching there? Have you heard about the chlorofluorocarbons which release these halogens, which have been indicted as the primary cause of the loss of the ozone or the ozone hole? Have you heard about it? The chlorofluorocarbons. Who is making those chlorofluorocarbons? It is the human made. तो ह्यूमन मेड चीज वहां पे कैसे पहुंच गई जब ट्रोपोस्फियर में के ऊपर देयर इज ट्रोपोपॉज लिड एंड इट इज स्टॉपिंग, इट इज नॉट अलाउइंग एनीथिंग टू गो अपवर्ड्स. Can you understand? It will be this type of phenomena which can carry those CFCs in the stratosphere, and then they are further distributed by the winds prevailing in the stratosphere, and that essentially has become the cause of the ozone hole. Okay, one of the cause, not the only cause. Okay, so that is basically about the lid. One thing is very clear. Can you understand when you are talking about the tropopause or troposphere? There can be spatial and seasonal variations also can be there in the tropopause. So हमने already देखा है कि the height of the tropopause it varies with latitude. We have already seen that. Then the height of the tropopause also varies with season. Now tell me, the height of the tropopause will be higher in summers or winters? Use the same logic which we have used in case of height, explaining the height of the tropopause. It will be higher in summer or winter. फटाफट सोच के बताओ. यूपीएससी में जब प्रीलिम्स का एग्जाम दोगे तो यू विल नॉट हैव दिस मच ऑफ टाइम. You have to develop this thinking, critical thinking, to do it faster. Yes, very good. So height again varies with season, and it will be higher in summer than in winter. Okay. Can we say height of tropopause will also varies with pressure systems? It will also vary with the pressure systems. So tell me, the height of the tropopause will be higher in a low pressure system or high pressure system. If on the surface there is presence of low pressure, on the other hand there is presence of high pressure on the surface, in which case you will find that the height of the tropopause will be variable. जल्दी से बताओ. हाई प्रेशर में ज्यादा होगा या लो प्रेशर में ज्यादा होगा? Very good. It will be in the low pressure zone. It will be higher than the high pressure zone. Or I hope you already understand, because in low pressure air is rising upward, in high pressure there is subsidence of air taking place. So this is about the phenomena of, if you talk about the tropopause. And if you talk about the troposphere, role in geography and weather. We have already seen on the surface weather phenomena, climatic variations are produced by what? They are produced by the changes which are taking place in the weather. So does it also impact the life which is present on the earth surface? Yes. Does it also impact the geography very, very strongly? Okay. So this is the case of tropopause. आगे बढ़ते हैं troposphere. Now moving towards the next, that is stratosphere. Stratosphere. So one thing we have already seen about the stratosphere, it is एक तरह से क्या मैं इसको बोल सकता हूं? Can I call it as the stability layer? Can we call the stratosphere as the stability layer? तो हाइट ऑफ द, इसका सबसे पहले अगर हम बात करें स्ट्रेटोस्फीयर में, द एक्सटेंट ऑफ द स्ट्रेटोस्फीयर वी हैव सीन दैट इट्स लोअर लिमिट इज फ्रॉम 8 to 18 kilometers and its upper limit is 50 kilometers. So it varies from latitude to latitude, the lower limit as we have seen, but upper limit is constant near 50 kilometer. Okay, where we have seen that there is the boundary. At this point, there is the boundary, which is, we called it as the mesopause. Okay, now, so that is basically what is happening in the stratosphere. अब यहां पर हम इसको सबसे पहले बात करते हैं कि why we are calling it as the stratosphere. Why called as stratosphere? Okay, so what is the case is that unlike the troposphere, there is very little vertical mixing taking place in this layer. Very little vertical mixing is taking place in this layer. Okay, and the air which is present in this layer, it is more stratified, present in strata. Okay, so the air of this layer is present in more stratified manner. ठीक है, and that is the reason we are, because it is present more like stratified, we are calling it as the stratosphere. That is where the name stratosphere comes from. ठीक है, I hope it is clear. Okay, then if you talk about the thermal characteristics of this layer, so there is the lower stratosphere. So in lower stratosphere we find that isothermal conditions are prevalent, while there is rest of stratosphere we find that temperature rises with altitude. ठीक है, we have seen that reaches to near 0 degrees Celsius at Stratopause. 0 degrees Celsius at the Stratopause. ठीक है, so it is rising with altitude. Ideally यहां पर क्या होना चाहिए था? Temperature should have declined with altitude, but now what we are finding, temperature is rising with altitude. Can we say that there must be something, some heating taking place in this zone? ठीक है, so what we find here, this rise of temperature is related with absorption of ultraviolet rays by ozone molecules concentrated in this zone. ठीक है, so what is taking place? That means why this height, why this temperature is rising? Due to, we can use one word, selective absorption of UV rays by ozone. There is selective absorption of the UV rays by the ozone. I hope it is clear. Tell me, why the temperature is rising in this zone? And that is why we were seeing that there was ozonosphere was present within this stratosphere. Rise समझ में आ गया? Rise of temperature. Now I will explain isothermal. ठीक है, why anywhere the isothermal conditions would be found? Think about this. We are approaching towards the winters. Okay. Now tell me, suppose if you cook your food at some winter night, you have cooked your food, and but you thought, yeah, let's take shower and then let me eat my food, then it will be like more pleasant I will feel after taking the shower. Now the problem is, if I keep that cooked food, by the time I come back from shower, is it possible that that food will become cold because it is winters? Tell me, yes or no? Is it possible that that food can become cold? हो जाएगा. So tell me how you can make sure that you keep the temperature of the food at same which you want. कैसे कर सकते हैं? How I can make sure that the temperature of my food remains same? Okay, put it in a tight container. Suppose I am a poor person, मेरे पास tight container नहीं है, गरीब आदमी हूं. what else you can do? Have you seen that many of the restaurants, some of the restaurants have started doing this, that they will put a candle beneath the container? Have you seen that? Like this, I have seen in one of these biryani selling restaurants. They are giving in that mud made pots, and they are also sending that if you talk about a candle burner. How many of you have had that biryani? किसने किसने खाया है? ठीक है, तो टेल मी, कैन आई कीप माई फूड एट सेम टेम्परेचर? सपोज मेरे फूड का टेम्परेचर वॉज, लेट अस से इट वॉज 50 degrees Celsius and I wanted to keep it at that same temperature of 50 degrees Celsius. ठीक है, but the problem is that my food which is at 50 degrees Celsius will keep losing heat. It will keep losing heat because surrounding temperature is cool. So it will keep losing heat, due to which what will happen? There will be decline in temperature taking place. Okay, so this will lead to decline in temperature. Now think about this. If suppose I keep a burner here and I make sure that the flame is at the same, as much as heat is being lost, same amount of heat is being added, will I be able to keep my food at 50 degrees Celsius? Tell me. Yes, Prakash, correct. It is biryani by kilo. Their Lucknow biryani is very tasty, although not so much tasty as the original Lucknow. Will I be able to keep my food at 50 degrees Celsius fast? Obviously, yes. So can you understand now why these isothermal conditions would be found? This, if you talk about as you are going upwards, what is happening with the density? Can I say here there is more dense atmosphere, here there is less dense atmosphere. So as I keep going upwards, what will happen with the density? It keeps on declining. So because of that, have we seen that there is lapse of temperature taking place? Yes or no? There is lapse of temperature taking place. Okay. Now think about this, that if same amount of that selective absorption, jitna heat lapse ho raha hai, how much heat is lapsed here, same amount of selective absorption of UV rays is taking place, will this means that the condition will remain isothermal? Does it means that the conditions will remain isothermal? Obviously, yes. Okay. So how much lapse is taking place? It becomes equal to the selective absorption of UV rays, or we can say heat produced due to selective absorption of the UV rays. Some of you had asked, one of you had asked about isothermal. I hope it is clear now. Isothermal. Okay. That is why if you talk about the atmosphere in certain zones will remain isothermal, because the amount of heat essentially being lost becomes equal to the amount of heat which is gained. ठीक है, अब वो इक्वल कैसे हो जाता है, बाद में कैसे बढ़ जाता है, नाउ वी आर गोइंग टू टॉक अबाउट दैट. ठीक है, तो वी आर सेइंग दैट इन द स्ट्रेटोस्फियर देयर इज प्रेजेंस ऑफ ओजोन. ठीक है, तो व्हाट हैपेंस, ओजोन इन द स्ट्रेटोस्फियर, इसको मैं डायग्राम से ही बनाता हूं इनफैक्ट. तो we are saying that it is something like this. So here it was 8 to 18 kilometer, and here if you talk about, we are saying that this is 50 kilometer, 50 kilometers. ठीक है, so what you are finding is something like this will happen, that एक एवरेज अगर हम मान लें तो let us take this as 20 kilometers height, and this, if you talk about, if I take this as the 30 kilometers height. ठीक है, this layer, in fact it varies from 30 to 35 because this layer has maximum concentration of ozone. ठीक है, the layer which is present above it, here what you find, there is maximum formation of ozone, यहां पर हो रहा है, बट मैक्सिमम कंसेंट्रेशन उसके नीचे मिल रहा है. ठीक है, हियर व्हाट यू फाइंड, देयर इज लोअर formation as well as concentration in the lower part. ठीक है, बात समझ में आ गई? Have you understood? Have you got this what? Then I can go to why. ओके, तो देखो, इसको समझने के लिए हमें सबसे पहले क्या समझना पड़ेगा, वी हैव टू टॉक अबाउट द चैपमैन साइकिल. ओके, सो चैपमैन साइकिल क्या करता है, इट एक्सप्लेन्स the presence of ozone. So if you talk about it, how it explains the presence of ozone, we already know that what happens, the oxygen, if you talk about, present here, it is able to absorb certain, when we are saying ultraviolet rays, even within ultraviolet rays there is a spectrum which is present. So it is able to absorb certain spectrum of ultraviolet rays. ठीक है, so it absorbs UV rays. ठीक है, and because of that it splits into two oxygen, if you talk about atoms. कल हमने देखा था, we called it as photo dissociation. ठीक है, now what will happen, this oxygen atom can combine with the oxygen molecule to form, ठीक है, to form ozone molecule. ठीक है, this however, ये जो सेकंड है कॉम्बिनेशन, combining, ठीक है, we are talking about this combining के लिए एक प्री कंडीशन चाहिए. व्हाट इज दैट प्री कंडीशन? देयर शुड बी प्रेजेंस ऑफ चैपमैन कांस्टेंट. जब चैपमैन कांस्टेंट मिलेगा देन ओनली दे कैन कंबाइन टुगेदर. आई होप इट इज क्लियर. ठीक है. अब व्हाट इज चैपमैन कांस्टेंट? चैपमैन कांस्टेंट एक्चुअली इन वेरी सिंपल टर्म्स यू ट्राई टू अंडरस्टैंड इट. चैपमैन कांस्टेंट इज concentration of air. That means it is related with density of air. Tell me, if there is this condition A and this condition B. In condition A, oxygen molecule is present here and oxygen atom is present here. In condition B, the oxygen molecule is present here and oxygen atom is present here. In which of these do you think, A or B, there is greater probability that they will combine with to form ozone molecule? Tell me. In which do you think that there is greater probability? A में या B में? Obviously it will be in B. There is higher probability because they are more near to each other. ठीक है. It is as simple as that. If suppose I have my friends, but meeting them, if we are living far away, will be rare. My chances of meeting my neighbor will be higher than meeting my friend who is living far away. ठीक है. So Chapman constant is basically what? That is, Chapman constant is a minimum if you talk about density which is required for combination to take place. I hope it is clear. Tell me. Have you understood this formation of ozone? So there is, this part is referred to as the formation of ozone. Okay. It is referred to as the formation of ozone. Now tell me what will happen. Can I say that if there is presence of ozone, we know that it is also absorbing the UV rays, ultraviolet rays. Okay. And if it is absorbing the ultraviolet rays, tell me, there will be again dissociation of oxygen molecule and oxygen atom into these two. Okay. So ozone will dissociate. ठीक है. So चैपमैन साइकिल क्या होता है? It talks about formation of ozone and dissociation of ozone. So these are constantly taking place, as a result of which what will happen? There is continuous formation, there is continuous dissociation of ozone, and ultimately there is ozone maintained in the stratosphere. Okay, tell me, is the stratosphere also an open system? And what happens if there is no external change taking place? Can I say these two will reach a condition of equilibrium? Yes or no? Over a period of time, can I say they will achieve equilibrium condition? And if they are achieving this equilibrium condition, that means formation will become equal to the dissociation. So will this lead to maintenance of the ozone layer. ठीक है, so it will lead to, as a result, ozone layer persists. ठीक है, so that is what is taking place. Now when we are talking about particularly, अब हमने दो चीजों की बात की, dissociation and formation. ठीक है, so मैं यहां पर लिख देता हूं factors which are affecting the formation. ठीक है, this formation will be, one important factor is the amount of UV rays. ठीक है, and it will also depend upon the density. ठीक है, on the other hand, dissociation, if you talk about, will be function of only one factor, and that will be amount of UV rays. Is this point clear? Because if this is clear, then only we can understand the distribution of ozone within stratosphere. Tell me fast. Okay, now think, हमने क्या बोला? We said actually it is like something like 20 किलोमीटर से लेकर के हम इसको मान लेते हैं 40 किलोमीटर्स, एंड 42 इधर कर लेते हैं 60 किलोमीटर्स. आई एम नॉट जस्ट टॉकिंग अबाउट स्ट्रेटोस्फीयर, आई एम जस्ट टॉकिंग अबाउट प्रेजेंस ऑफ ओजोन. So there is below 20 kilometer, there is above 60 kilometer. We are also taking that into account. So here, if you talk about, there is least formation of ozone. Above 60 kilometer, there is hardly any formation of ozone taking place. Okay. Here there is maximum formation of ozone. Here there is maximum concentration of ozone, and here there is lower concentration of ozone. ठीक है, so this is the phenomena which is taking place. अब एक एक करके बात करते हैं. सबसे पहला, सबसे ऊपर वाले को लेते हैं, लीस्ट फॉर्मेशन ऑफ ओजोन. एक और फैक्टर देख लेते हैं, अमाउंट ऑफ यूवी रेज. तो टेल मी, इफ वी टॉक अबाउट अमाउंट ऑफ यूवी रेज, कैन आई से एज आई गो डाउनवर्ड्स, शुड इट डिक्लाइन, शुड इट बी लाइक दिस, अमाउंट ऑफ UV rays, should it be like this as I go downwards? It is like this. ठीक है, तो इसको मैं दिखाता हूं एक. तो can you see this? This is the ultraviolet radiations. So as ultraviolet radiations go downward, can you see, because they are being absorbed in the upper layers, so less and less radiations will be able to reach as you keep going downwards. I hope it is clear. So that is the amount of UV rays. So let us start. First हम बात करें least formation of ozone. Who will tell me why there will be least formation of ozone here? जबकि वहां पे तो maximum UV rays है, हमने देखा है. फैक्टर फॉर्मेशन किस पे डिपेंड करता है? It depends upon amount of UV rays and density. So why there is least formation of ozone there? Tell me. Why there will be least formation of ozone here? Can we say because there is no enough density and due to which the Chapman coefficient or Chapman constant is not found? Okay. So here if you talk about because there is lack of Chapman coefficient. ठीक है, एक्चुअली मैंने उसमें एक करेक्ट कर लो एक चीज, मैंने शायद कांस्टेंट वर्ड यूज कर लिया. इट इज चैपमैन कोएफिशिएंट. प्लीज करेक्ट इट. It is actually Chapman coefficient. So there is lack of Chapman coefficient, not enough Chapman coefficient is present there. ठीक है, तो वहां पर इसलिए फॉर्मेशन ना के बराबर हो रहा है. यहां पर जब मैं जैसे ही आता हूं, मैक्सिमम फॉर्मेशन ऑफ ओजोन इज टेकिंग प्लेस. ठीक है, तो व्हाई? बिकॉज कैन आई से if you compare these three layers, ठीक है, 40 to 60, 40 to 20 and below 20, which will be receiving maximum UV? 40 to 60 will be receiving maximum ultraviolet radiations. So can we tick the first factor to be very positive? Yes or no? Second, here has the density also increased. There is enough Chapman coefficient present. Okay, so that's what will happen here. There is maximum formation of ozone. The problem is that if there is high amount of UV rays are available, does it also means that in this layer there will be maximum dissociation of ozone also taking place? Tell me. फटाफट बताओ यार. ठीक है, तो देयर विल बी मैक्सिमम डिसोसिएशन. सो यहां पे फॉर्मेशन सबसे ज्यादा हो रहा है लेकिन कंसेंट्रेशन उतना नहीं है. बट व्हेन आई एम कमिंग हियर, टेल मी, कैन वी से कि डेंसिटी हैज इंक्रीज्ड हियर, although there is amount of UV rays have become lesser, but can I say they are still enough and density has further increased? Because of that, what will happen here also there will be enough formation, but because the amount of UV rays are comparatively less than here, tell me, there is not so much of dissociation taking place. Okay, and essentially you will be finding within this layer thus maximum concentration of ozone will be found. I hope it is clear. When you go further down, lower concentration of ozone will be found. Why? Because although here density becomes even higher, ठीक है, problem is that very limited UV rays are reaching here. Thus the phenomena of formation cannot be so much effective. समझ में आ गई बात? Tell me. Now, can you also understand that why, when we are talking about the lower stratosphere, there is isothermal conditions? Because इस समय जो selective absorption हो रहा है वो limited हो रहा है. The selective absorption of UV rays is limited because there is limited ozone only, and thus it is matching that lapse. But as you go upwards, there is more ozone now available, there is more absorption of UV rays is taking place, there is more formation, there is more destruction. ठीक है, so इसको dissociation लिखा है, इसको destruction भी लिख सकते हो. Destruction is actually a better word. So there is more destruction of ozone also taking place, and thus more and more heat is produced, and thus the temperature rises. So this is what is occurring in the stratosphere. ठीक है, so that is the case. अब स्ट्रैटोस्फीयर में एक और चीज होती है कि देयर इज if we talk about the stratospheric or weather, what about the weather conditions in the stratosphere? ठीक है, so what we find, there is some weather events can do occur. Some weather events can do occur in the stratosphere. Okay, and if you talk about one important weather event which is occurring in the stratosphere is the presence of polar stratospheric clouds. So one major weather event which is taking place is the polar stratospheric clouds. और polar stratospheric clouds नाम से ही पता चल रहा है कहां पर मिलेंगे, पोल्स में पे मिलेंगे. They are primarily present at the height of around 20 to 30 kilometers. ठीक है, and if you talk about this 20 to 30 kilometer in the polar winter, so particularly they are present in the at the time of polar winters. ठीक है, and if you talk about, they are also they are very like shining type of clouds. They are also referred to like pearl, you would have seen. They are also referred to as mother of pearl clouds. They are also referred to as the mother of pearl clouds. They are primarily made up of what? Water, ice particles and nitric acid. So they are primarily made up of nitric acid and water, ice. ठीक है, and what is a very important thing which is taking place is that they facilitate, they behave as a catalyst in the destruction of ozone along the poles. So they behave as a catalyst in the destruction of ozone in the stratosphere over the poles. ठीक है, क्योंकि ये क्लाउड्स कब फॉर्म हो रहे हैं? विंटर्स में फॉर्म हो रहे हैं. विंटर में यू मस्ट बी अवेयर, पोलर विंटर में क्या होता है? डज देयर is there availability of sunlight in polar winter? Is there availability of sunlight in the polar winters? There is no availability of sunlight in the polar winters. ठीक है, पोलर एरियाज विंटर्स में कोई सनलाइट रिसीव नहीं करते हैं. यू मस्ट हैव हर्ड दैट देयर देयर इज नाइट फॉर 6 months. ठीक है, so there is no sunlight available. What will happen after the winters are over, when there is springs coming? Sunlight will return. ठीक है, and if sunlight returns, can I say the UV rays will also return? And UV rays essentially what they will do, they will lead to destruction of the ozone. In the presence of these clouds, what will happen? They will become more active. So देखो, इसको मैं थोड़ा सा दिखाता हूं यहां पर, you'll better understand it, how the destruction of ozone is taking place. So again, we've already talked about these things. So ozone depletion. So there is ultraviolet rays which are coming. So can you understand, there were these CFCs which have been used, for example, coolants for refrigerators, air conditions. Now you know कि Montreal Protocol, we disbanded the use of these because we ultimately understood they were the problem. Cleaning solvent for electric components, production of certain plastic foams, propellants of aerosol sprays, number of things. ठीक है. What is the very important thing about these chlorofluorocarbons? They release halogens. ठीक है. So if you talk about when the CFCs go upwards in the atmosphere or in the stratosphere, if they are able to reach in the stratosphere, we have already seen how they can reach. They can breach sometimes the tropopause lid and they can reach. So if they reach in the stratosphere, they can come in contact with these stratospheric, polar stratospheric clouds. And under the influence of this polar stratospheric clouds, what will happen? It is they will get dissociated and halogens like chlorine will be released from those chlorofluorocarbons. Now what will happen? ये जो halogens होते हैं chlorine, when they reach stratosphere, they have a very long residence time. They can reside there for long period of time. ठीक है. So this chlorine, what it will do? It can combine with the, it can chemically react with the ozone molecule and there will be formation of chlorine monoxide, and what will happen? Oxygen molecule will get split. ठीक है. So this is the first step. आगे क्या होगा? Now this chlorine monoxide is very unstable and it can further combine with the single atom of oxygen which was there. वो वेट कर रहा था कि दूसरा उसका ऑक्सीजन मॉलिक्यूल आए और दोनों मिल करके फिर से क्या बन जाए? दे बिकम ओजोन मॉलिक्यूल. बट उससे पहले कौन आ गया? विलेन आ गया. क्लोरीन मोनोऑक्साइड came and again it chemically reacted with the single atom of oxygen, due to which again it will become free. And what will happen? Oxygen molecule will be formed. So can you see that one chlorine which is present, it will go through this multiple cycle. One chlorine can destroy many ozone molecules. Okay, and it remains there for a long period of time. I hope it is clear. So thus can you understand that because of the formation of these clouds, there is what? They behave as catalysts in the destruction of ozone in the stratosphere. Over where? Over the poles. And can you understand, this is leading to the development of what you call it as the phenomena of ozone hole. Okay, so in this fashion, if you talk about, there will be ozone hole formed. I hope it is clear. अगर क्लियर है तो मैं आगे बढ़ूं. Then फर्स्ट वेदर फिनोमेना वो था. सेकेंड वेदर फिनोमेना हम देखेंगे that the second weather phenomena is presence of stratospheric jet stream. ठीक है, और this is also referred to as polar night jet stream. ठीक है, तो हम देखेंगे कि what later actually jet stream is not at this point, it is a more dense concept, so this is not the place to read about that jet stream. Just remember that suppose you are talking about the earth, so suppose this is the pole and it is winter time, so here what happens, suppose ये हमारा around 66.5 degree latitude है, ठीक है, एंड सपोज ये नॉर्थर्न हेमिस्फीयर की हम बात कर रहे हैं, तो इन द स्ट्रैटोस्फीयर, ठीक है, देयर इज प्रेजेंस ऑफ फास्ट मूविंग लाइक दिस काइंड ऑफ जेट स्ट्रीम. ठीक है, at so much height, very fast moving jet stream is present around, circling almost around the poles in the subpolar region. So this jet stream which is present there is referred to as what? The polar night jet stream. ठीक है, and can you understand कि very important role will be played by this polar night jet stream if it is circulating like this, very fast circulating like this. Tell me, can we say this polar air will not be able to mix with subpolar air? तो उसको अलाउ ही नहीं करेगा सबपोलर एयर के साथ मिक्स होने के लिए. ठीक है, एंड एज अ रिजल्ट दिस पोलर वॉर्टिसेस, बाद में हम एक कंसेप्ट पढ़ेंगे, पोलर वॉर्टिस विल बी फॉर्म्ड. ठीक है, द एयर इफ इट इज अनेबल टू मिक्स विद द सबपोलर एयर, इट विल कंटिन्यू टू गेट, द पोलर एयर विल, stratospheric air will continue to get cooler and it will begin to do what? Become very heavy and subside. It will push downwards, due to which this polar vortex, if we talk about, will be further pushing in the polar region, even within the troposphere. ठीक है, and due to which what will happen? The anticyclone present at the poles, the high pressure present at the poles, it will become very strong. ठीक है, so this is another type of weather phenomena taking place in the stratosphere. One thing is very clear from this weather phenomena which I talked about. Can we say that there are enough evidences to suggest that there is a strong, or there is a clear interaction between troposphere and stratosphere? अगर सपोज करो कि यहां से जो स्ट्रैटोस्फीयर में की जो विंड, जो एयर है, इफ इट इज सबसाइडिंग, एंड एज इट इज सबसाइडिंग, इट इज ऑल्सो पुशिंग द एयर विच इज प्रेजेंट इन द ट्रोपोस्फीयर, ड्यू टू विच देयर इज वेरी स्ट्रॉन्ग हाई प्रेशर कंडीशंस क्रिएटेड इन द पोल्स. डज इट मीन्स दैट देयर इज सम इंटरेक्शन बिटवीन स्ट्रैटोस्फीयर एंड ट्रोपोस्फीयर? दैट मीन्स what is happening in the stratosphere, does it means that it will control also the weather phenomena in the troposphere or on the surface of the earth? Tell me. Yes or no? Is it possible? ठीक है, so that is how, if you talk about, there is all these things, if you talk about, you need to know about the stratosphere. और कुछ खास नहीं है, जो बाकी चीजें हैं, like there is more complicated things which are present, like just for the prelims sake मैं बता देता हूं, there is a something referred to as quasi-biennial oscillations which are taking place in the स्ट्रैटोस्फीयर. और ये क्या होता है कि उसमें ईस्टर्ली वेस्टर्ली जो विंड्स के डायरेक्शन जो हैं वो चेंज होते रहते हैं. ठीक है, पर्टिकुलरली इन द ट्रॉपिकल स्ट्रैटोस्फीयर में. So again, if suppose there is a statement like this in the prelims, this is not very important from our mains point of view. Okay, so remember just that. There is nothing much more which I really believe that is relevant from our point of view. So that is about the stratosphere. I think it is enough for today. I am purposefully going slow in the first part of this basic climatology में मैं बहुत slow चल रहा हूँ. Reason being कि ये basic climatology, if anyone can understand, master the first part, basic climatology, advanced climatology will be so much easy for that person. So again, I would remind you that what you have to do, make sure that you revise, क्योंकि जैसे जैसे we will move forward, everything, all these concepts, small concepts, they will keep on accumulating, they will be used many times. And if you don't remember, you will not be able to relate. And thus what will happen, you will not be able to understand it. Okay? Any question anybody has to ask? Tell me. किसी को कुछ पूछना है? Hopefully you enjoyed the class today. I can promise you one thing. If you just do what I am saying, that keep revising it, by the end we complete climatology, you will see that not a single question, conceptual question, will be beyond what you are able to do. चाहे वो प्री का हो, चाहे वो मेंस का क्वेश्चन हो, सारे के सारे कर लो. ठीक है? So we'll stop for today. Revise it, because now we have entered into that main climatology, the basic one. ठीक है? So we'll talk about mesosphere, we'll talk about the thermosphere, then we'll move on, we'll talk about the seasons, and then we'll move on to the insolation and heat budget. ठीक है? And I have, as I have told you before also, this year I have updated the content heavily. तो बहुत मजा आएगा. क्लाइमेटोलॉजी वैसे भी जिसको थोड़ा सा लॉजिक पसंद है, ठीक है, एनीवन हु लाइक्स लॉजिक एंड प्रॉब्लम सॉल्विंग, those people will in fact fall in love with climatology. Okay, so we'll stop for today. Goodbye, take care. We'll meet on Monday. We'll continue with this. The class I will continue on YouTube till the basic climatology. When we'll enter into advanced, then we'll shift to our Janadar, actually I'm taking this class from my studio at home. So in my home studio also I have set up this full setup I have made. Okay. Okay. Goodbye, take care. मिलते हैं on Monday.